we are continuing Chapter 9, Section 1. Before we get started, we want to say shout out to Jordan, who will be watching this video from home because she's at home sick right now. So hopefully this will help you. After watching this video, I would want to watch the previous video to help you with the other problems. We're going to be starting with simplifying each expression. Right now, we have 2 to the power of radical 2 times radical 8. What I'd like you guys to do on your paper right now is to highlight or circle something with those 2 numbers and put a little arrow right here and write power of a power. Now, in your little chart or table, you should see this. A to the power of n raised to the power of n is going to be the product of n times n. So whenever you have a power to a power, you multiply those powers together. What is 2 times 8? So that's going to be 2 to the power of radical 16. Well, wait a second. What can we do with this radical 16?
Simplify it.
To what? 2 to the what?
4.
Can we go even further? 2 to the power of 4 is the same as a certain number. Let's do 16. It is 16. So ready? You didn't know that? Remember, 2 to the first is what? 2. What is 2 squared? 4. What is 2 to the third? 8. Keep going. What's 2 to the fourth? 16. Now, over here, watch what we're about to do. We're going to do something a little bit different in preparation for what's going to come soon to the classroom near you. 2 to the negative 1 is 1 over 2. 2 to the negative 2 is 1 over 4. 2 to the negative 3 is 1 over 8. You're not going to believe what 2 to the negative 4 is.
1 over 32.
He was just joking. It is 1 over 16. Now, there's something I did not mention, but something you do need to know. 2 to the power of 0 is the number 1. Any number to the power of 0 is simply the number 1. This right here, you could do with any base number. When I say base number, I'm referring to this as a base 2. Not counting system base 2, but just this right here is the base. This number right here is considered to be what's called the exponent. Okay? So, continuing on with this investigation, let's go to problem number 14. Do we have a power to a power in this particular case?
Yes.
Yes. Which means we're allowed to take 3 and multiply it to 75, which gets us the product of 220. Oh, I like the square root of 225. It's right, because the square root of 225 is the number 15. How much have we used the calculator thus far?
0.
0. We're going to keep going without the calculator. Does everybody realize that there is a portion of the SAT math test where you're not allowed to use 14? Boom! Into the 3 times 75. Square root of 225. Square root of 25 is 15. I realize it sounds like we're going fast. We're just going efficiently. Could you all put 1 in front of this radical 6 just to make it a 1 radical 6? Now, anytime you see a little dot right here, that means you're multiplying, right? This lets you know you are not dealing with the power property. You're dealing with what's called the product property. Now, we're going to review the product property. So what I want you to do on your paper right now is write this. A to the power of n times a power of n equals a to the power of n plus n. In the product property, what are we allowed to do with this exponent right here and this exponent right here? This is when you add, you're right. This is when you add the exponents together. So if you have 1 radical 6 and you add a 5 radical 6, how many radical 6s do you have? 6. So your final answer, everybody, is 6 radical 6. Now if that didn't make sense to you, I'll do it the slow way. Here we go. Here's the slow way. Y is 1 radical 6 5 radical 6 yields us the answer of y to 6 radical 6. You got to see it visually. That's what it looks like visually. This is not too bad. Not too bad. Ooh. All right, everybody, what kind of property are we dealing with right here? Product or power? Product is correct. Because of that right there, that lets us know we're dealing with product. Property. Forgot to tell you guys yesterday, but my daughter came home. She said, subscribe to your YouTube channel. She's like, I have no idea what you're talking about, but I just figured it's cool.
Oh.
We're like, thank you. Now, could you guys right now write 13 to the power of radical 6 less radical 4? Now we have a problem. The problem is you cannot add radicals together unless they are the exact same type of radical. So let me make sure you understand what I'm saying. A radical 2 plus a radical 2 becomes 2 radical 2s. If I have a radical 10 and I add another, let's say 2 radical 10. You can add those together because they're both radical 10s. That would become a 3 radical 10. But if you have a radical 2 plus a radical 3, that just is radical 2 plus radical 3. You can't simplify it because they're not the same radical. So over here, if you look at it, the first thing you look at is, wait a second, these aren't the same radical. But if you look closer, one of these you can simplify. One of them is already simplified. Which one do you think we can simplify? This one or this one? 24. So right now, what I'd like you to do on your paper is simplify radical 24. If you're watching this video, you need to pause it right now and try to simplify the square root of 24 on your own. So pause it right now because we're going to pause it. Now, 24, everybody, breaks down to a lot of different factors, but we're just going to use the factors 4 and 6. And 4 breaks down into 2 and 2. And even though you can't see it, there's a little index of a 2 right here because all square roots look for groups of 2. And I have a group of 2. Now, a 6, some of you are like, wait a second, you can break down a 6, yes, to a 2 and a 3, but you don't have a pair of them. So your final answer for the simplified version of the square root of 24, or radical 24, is 2 radical 6. Oh. The 2 comes out, 2 times 3 is 6. So watch what we're going to do. I'm going to erase this right here. Watch this. Take it, erase it. Going to replace it with 2 radical 6. Because radical 24 is simplified to 2 radical 6. So what is 1 radical 6 plus
3 radical 4.
2 radical 6? 1 radical 6 plus 2 radical 6 is 3 radical 6.
That's what I just said. I know it.
Yes. Okay. Don't worry, I won't rewind the video. Alright? There we go. 13 to the power of 3 radical 6 is your final answer. This is cube code. Once again, no calculators used. Now, everybody, this is the first time we've come across what's called the, no, not the coughing sound, called the quotient property. You know, I will have to say, it is kind of interesting when you're doing a video as a teacher. It seems like that's when everybody has a tendency to cough or sneeze or like they open up a bag of chips or they're drinking water or they felt or something ridiculous thing that happened.
Well, how do you hear someone's drinking water?
You know, it's just any annoying sound in the background you will hear. So sometimes you might just need to mute this particular video. Now, the quotient property states a to the power of n over a to the power of n. This is where you do what with the exponents? You're allowed to do what? Subtract. Which means, if I have n cubed, also known as n to the power of 3, divided by n to the power of pi, that cannot be simplified to a nice, neat answer. So you just have to write it like this. 3 minus pi. That's it. I don't want you to type this in the calculator and give me a decimal
You
equivalent.
get like point.
It's going to be a negative point something. Okay.
That'd be too much.
So we're not gonna put this in the calculator, all right? By the way, if you tried to write the approximate value for this, you would spend the rest of your life doing it and never get it done. This is where things, everybody, get interesting. This is the first one I'd like you to put into your journal. This is where things get interesting. Right now, you are dealing with what's called the quotient property.
You want us to put it in your.
Oh yeah, put this sucker in your journal right here. We're going to write 125 raised to the power of radical 11. And make sure, when you guys write this in your journal, make sure you take the time and energy to make it in the exponential area right here. Divided by 5. Raised to the power of radical 11. Now, I want you guys to understand that this number right here, 125, is definitely not the same as the number 5. So we have to figure out a way. How can we get these bases to be the same? Okay? Well, 5 to the first is just 5. 5 squared is 5. 5 cubed. Knowing that 5 cubed is 125 makes this very helpful. So I'm going to circle this. And I'm going to take this information right over here, and I'm going to erase the 125. And I'm going to replace it with 5 power of 3. So hopefully everybody can see that this number, 125, right here, is also rewritten as 5 cubed. Now, here, what property are we going to utilize right here? What property?
The
Power.
Right. Power of power. So power of power, we have 5. Oh, my board reset. Tell me what I'm going to write before I write it, Mr. Lewis. It's okay, I put you on the spot there.
33.
3 times a radical. Now, what you did is this. You did radical 3 times radical 11, which would be a radical 33. That's kind of what I think your brain. Okay. Now, keep doing that. Third time's a charm.
Sure.
Now, over 5 radical 11. Now, can everybody see clearly that we have the same thing? Now, we're going to use the quotient, right? So what am I going to do with 3 radical 11 and the radical subtract? So everybody, I want you to take 5 to the power of 3 radical 11 and take away a 1 radical 11. Now you don't have to put 1 radical 11. What's 3 radical 11s? Take away a 1 radical 11. So your final answer is 5 to the power of 2 radical 11. That's your final answer.
And it's a radical.
This is what's considered to be simplified. All right. Like I said, this is where things get interesting. Would you please put problem number 21? We're going to do problem number 21 next. In order to solve these problems, we need to first go over a concept. We need to go over the concept that x is definitely equal to x. If I say x to the first, then this would have to be x to the first. If I say this is x to the 10th, this would also have to be x to the 10th. If I say this is x to the 100, that would have to be x to the 100, and so on and so forth. Okay? If I said x to the power of a, then this letter would also be a, correct? What if I change things up and say x to the power of a equals x to the power of b? What do we know about the relationship between a?
Well, there's no.
A would have to equal whatever b is. If a is 2, then b is 2. If a is 3, then b is 3, and so on and so forth. If and only if these are the exact same base number. Do we have the exact same base number right here?
No.
No.
Yeah.
That's a 3. That's a 9, right? So that's a 3. That's a 9. So either we need to somehow find a way to convert a 3 to a base 9, or find a way to convert a 9 to a base 3. Nope. We have to convert base 9 to base 3. 3 squared is 9. So watch what I do. Ready? Right here, instead of the number 9, I'm going to write 3 squared, parentheses, 4n minus 3. There's the greater than symbol. 3 raised to the power 6n minus 5. Hopefully, you guys can see that 9 is 3 squared, and 3 is still just the number 3. Once you have done this, now do we have the same? You're right. They are the same. Since they are now the same base, we can set this guy right here less than this right here. Does everybody see that? So right now, what I'd like you guys to do is I'd like you to take 6n minus 5, make it less than 2 times 4n minus 3 in parentheses. What I need you to do now is do one thing and one thing only. We made this an Algebra 1 problem. I just want you to solve for n. Now, you can pause the video and try to do it, and then I will work through this last problem right here. All right, hopefully you were able to figure everything out. The first thing that I'm going to do is distribute the 2. And I get 8n minus 6. Now, this is my inequality sign. Since I have the most positive variables over here, what I'm going to choose to do is take away a 6n from this side and take away a 6n from this side, which means I need to add a 6 to this side and to add a 6 to this side. So we're going to go around and see what happens. I have a 6n minus 6n. That's a whole lot of nothing. I've got a negative 5 plus a 6. That's a 1, which is less than an 8n minus a 6n, which is a 2n. And here that just zeroes out. We have 1 is less than 2n. But we have the mathematical ability to say 2n is greater than 1. These mean the exact same thing. And then we're just going to divide both sides by 2. So n is greater than 1/2 is your final answer to this problem. In review, anytime you have one of these problems, you must change these numbers so that they are the exact same base. So that's what you're going to have to do before you start solving. Have a wonderful day.